children, I am Shushmita and today with me is Mohammad Rizwan. And welcome back. Previously, you have learned about acceleration due to gravity and free fall. Now, let us gather some information on thrust and pressure. Learning outcomes. At the end of this session, you will be able to understand about thrust, pressure, pressure in fluids, pressure due to liquid, pressure of air, atmospheric pressure, barometer, pressure at a depth h in a liquid, pressure difference at different levels of depth in fluids. Keywords: thrust, force acting perpendicular to the surface. Pressure, force exerted on a surface per unit area. Atmospheric pressure. Barometer measures atmospheric pressure. Before starting this session, let's look at this concept map. The force acting on an object perpendicular to the surface is called thrust. Let us try to understand thrust by considering the following situations. Suppose you wish to fix a poster on a bulletin board. To do this, you will have to press drawing pins with your finger on the board. You apply force on the surface area of the head of the pin. This force is directed perpendicular to the surface area of the board. Let us look at another situation to understand more about thrust. Suppose you are standing on loose sand. Your feet go deep into the sand. Now, lie down on the sand. You will find that your body will not go that deep in the sand. In both cases, the force exerted on the sand is the weight of your body. You have learned that weight is the force acting vertically downwards. Here, the force is acting perpendicular to the surface of the sand. When you stand on loose sand, the force, that is, the weight of your body, is acting on area equal to the area of your feet. But when you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. Thus, the effects of forces of the same magnitude on different areas are different. In the above cases, thrust is the same, but the effects are different. Therefore, the effect of thrust depends on the area in which it acts. The effect of thrust on sand is larger while standing than while lying. The thrust on the unit area is called pressure. Pressure is equal to thrust by area. Substituting the SI unit of thrust and area, we get the SI unit of pressure as Newton per meter square or Pascal, PA. The force acting on a smaller area exerts a larger pressure, and the force acting on a larger area exerts a smaller pressure. This is the reason why a nail has a pointed tip, knives have sharp edges, and buildings have wide foundations. All liquids and gases are fluids. A solid exerts pressure on a surface due to its weight. Similarly, fluids have weight and they also exert pressure in all directions and at all points of the fluids. Pressure exerted in any confined mass of fluid is transmitted, unaltered in all directions. When a balloon is immersed inside the water in a vessel, it immediately comes up and floats on water. This shows that water exerts pressure in the upward direction. Liquid pressure acts on lateral sides also. When a bottle having water is pierced on the sides, we can see water coming out at a speed. To understand the concept of pressure of air, let us consider an activity. Take a glass tumbler and stick some cotton at the bottom of it. Immerse it inversely in water up to the bottom of the container. Take the tumbler out of the water. We find that the cotton is not wet. This is due to the force of air which is applied to water by the air present in the tumbler and stops water from entering the tumbler. This force on a unit area of water is the pressure of air. All the objects on the earth are subjected to constant atmospheric pressure. Atmospheric pressure is defined as the force or thrust exerted by the atmospheric air on a unit surface area of the earth. Atmospheric pressure is equal to force of the atmosphere by surface area of the earth. Here, force can be written as weight. Atmospheric pressure is equal to weight of the atmosphere by surface area of the earth. Weight is equal to mass into acceleration g. Atmospheric pressure is equal to mass of the atmosphere into g by surface area of the earth. Mass is equal to density into volume. Atmospheric pressure is equal to average density of the atmosphere into volume of the atmosphere into g by surface area of the earth. Volume is equal to area into height. Average density is rho. Atmospheric pressure is equal to rho into surface area of the earth into height of the atmosphere into g by surface area of the earth. Atmospheric pressure is equal to rho into height of the atmosphere h into g. Atmospheric pressure is equal to rho into h into g. P naught is equal to rho h g. A barometer is a device used to measure atmospheric pressure. The first barometer was invented by Torricelli using mercury. This barometer consists of a glass tube of about 1 meter length closed at one end. The tube is completely filled with pure mercury such that no air bubbles remain inside it. The open end of the tube is closed with a thumb finger and then inverted into a bowl of mercury. The weight of mercury inside the tube exerts a thrust on the mercury in the bowl. At the same time, the atmospheric pressure acts on the surface of the mercury. When the thrust due to the mercury column is equalized by the atmospheric pressure, the mercury inside the tube reaches a steady height of 76 cm, leaving a vacuum in the upper part of the tube. This is known as 1 atmospheric pressure. Let us consider a container containing a liquid of density ρ and a cylindrical column of height h from the surface of the liquid of cross-sectional area A. The volume of the liquid column V is equal to AH. Mass is equal to volume into density. M is equal to AH rho. Weight is equal to mg is equal to AH rho g. The forces acting on the water column are weight W vertically down, force on the top surface due to atmospheric pressure P naught A acting vertically down, force on the bottom surface of the column due to static pressure of liquid PA acting vertically up. From Newton's law, we get PA is equal to P naught A plus W. We know that W is equal to AH rho G. Substituting it, we get PA is equal to P naught A plus AH rho G. Cancelling A from both sides, we get P is equal to P naught plus H rho G. This means that the pressure inside the liquid at a constant depth is constant. Let us consider a cylindrical column of liquid of height h with cross-sectional area A and let rho be the density of the liquid. The pressure P1 in the liquid at depth h1 is P1 is equal to P naught plus h1 rho g. Similarly, pressure P2 at depth h2 is P2 is equal to P naught plus h2 rho g. Solving both these equations, we get P2 minus P1 is equal to h2 rho g minus h1 rho g. P2 minus P1 is equal to rho g h2 minus h1. We know that h is equal to h2 minus h1. So, we have P2 minus P1 is equal to rho g h. The pressure difference between two levels in the liquid is equal to rho g h. Here, density of the liquid rho and g are constants. So, the pressure differences increase with an increase in depth. Points to remember. The force acting on an object perpendicular to the surface is called thrust. The thrust on the unit area is called pressure, and its SI unit is Newton per meter square or PA. Pressure is equal to thrust by area. The force acting on a smaller area exerts a larger pressure, and the force acting on a larger area exerts a smaller pressure. Pressure exerted in any confined mass of fluid is transmitted unaltered in all directions. Atmospheric pressure is defined as the force or thrust exerted by the atmospheric air on a unit surface. Atmospheric pressure P naught is equal to rho into H into G. A barometer is a device used to measure atmospheric pressure. The pressure difference between two levels in the liquid is equal to rho G H. Thank you.